Going live, going live. Oh, boom, this works now.
You're live.
Okay, I'm just gonna close this. This is the one that I'm on. I'm gonna close that. Okay, I'm live. Now I need to share this. Just copy that. Copy. You want to take care of the meetup, Henry?
So just put meetup into Look, this presentation, actually, the School of AI, this is a meetup that has over 400 cities in the world.
Yeah,
You know that.
I know that.
So-
Yeah, I know this is from the Siraj.
Yes,
and
yes. So this presentation, we have how they say this, a place where we can share what happened in our meetup
Right.
and recommend for everyone to disclose for their meetups. Would you like to permit to?
Sure. I mean, I think my company wants me to do something like this too. So why not?
You're admin.
Yeah, I'm admin. Yeah. Let me give you my card.
I'm going to give you my card, and I was at in Las Vegas in March for the IBM conference.
Las Vegas IBM conference.
Think.
When did this year?
Yes.
You were there?
Yes, we won the IBM's best business partner in Brazil. We are the largest seller of Watson solutions in Latin America.
Really? But now you come here.
I live here for a while. I'm the chief of innovation. And
Oh, really?
here we created new solutions,
I see.
new products.
Oh.
John.
Oh, yeah. Something with Chang Dang. Yeah.
No, but the Z is J, right? John.
Zhang, yeah. That's the Chinese people from like Hong Kong or Taiwan. Mostly they spell as CH. Yeah. So you full time doing the startup or you're?
No, it's not a startup.
Okay, guys, we're live.
We're live.
Yeah, we're live. One of the people just said, "I see you," so we can get started whenever.
Good news.
Okay.
So,
Maybe you can make a small announcement.
Okay, I guess.
what time is it?
6:51.
Yeah, 6:51.
6:50. Okay.
Want to wait till 7 or just get started?
We should start, right? Yes.
How long does a presentation take approximately?
45 minutes.
Awesome.
I can make it longer or
Hey,
shorter,
guys.
however you want.
We're going to start our meetup today. I'd like to present Andrew here. He's from IBM, and he's going to show us how to easily deploy one AI solution, industry level solution with a high accuracy using Watson, right? And thank you very much for being here. And please.
Okay, thank you everybody for coming. I know it's a rainy day. I live in Bridgewater, so I drive like about 45 minutes over here. But thank you for giving me this opportunity to meet people, learn something together, and I'm happy to have a more interactive discussion during this talk or maybe after also. Okay. So a little bit, few words about myself before I get to the agenda. Before I get to the agenda.
Please, just unhook that electric power. The speaker. That's a surplus.
Can you hear me okay?
Yeah, go ahead.
Yeah. So I've been working with AI or machine learning for the most part the last 2 years since I joined IBM. Before that, I was working on big data analytics and some of the clouds, both AWS and IBM cloud. So today, my agenda here is this. It's going to be like a 45 minutes. If I have time or people have interest, I can give some demo. It depends on how many questions I got. So first, I will get a very brief introduction of machine learning, deep learning, and AI, and how this fit into from the relationship between these different concepts and use case. Then I will get into a little bit about in enterprise how AI and machine learning and being deployed. Then I'll talk about a little bit about cloud and how machine learning or deep learning can be provided as a service on cloud, which is right now called machine learning as a service or deep learning as a service. But having a machine learning or machine learning model or machine learning service is not the end of the solution. The final mile usually land into application. So I'll talk about a little bit about how to take what you build with the model and deploy that as an application, right? If I have time, I can take a demo. I have some my own. Usually, I give us some my personal takeaways and share with you guys. Should I get some time? Yeah. So, future of technologies, right? I'll say this is published as Gartner in July or August this year. This is what they call a hype circle for emerging technologies. If you look at this, the technology comes with a curve. The emerging means like the very steep going up, and then may go down, and then stabilize. And this cycle depends on the technology. Sometimes it takes 2 years to 5 years, sometimes it takes 5 to 10 years. And industry-wide, people are constantly reading what's happening today, because nobody can predict the future very easily. And I think as students or professionals, we all try to understand which one is the right direction for us to take. Sometimes you pick too early, and then may not landed with the result you're looking for. Sometimes you take too late, then opportunity window disappeared for you, right? So that's this chart I want to share with you. But a couple of things I want to quickly give to you is, if you ask me what's happening in the computing or in enterprise, the number one thing probably is cloud. Which means the cloud offers the very comprehensive portfolios in terms of product to fit or map into enterprise solutions, from infrastructure to platform to software, right? The other one is data. People call data nowadays, but really it's big data in the old 5-10 years ago. But people no longer treat big data as special. They are data. Small data, big data, you are actually, when you deploy the solution, you're going to use the same type of framework to solve both small data or big data problems, right? And then is artificial intelligence. I was joking, sometimes people, 2-3 years ago, people talk about, machine learning. Then last year, with all the conferences, is like a deep learning. But this year, you go to this conference, they all change the name, called AI. But basically, it's a different term, but it's different, flavor. But really underneath there, the core is the same. By using data to learn and predict, right? I spent quite some time early this year learning and doing blockchain. In fact, I'm actually working with someone writing a book on that. Right? So what I'm trying to tell you here is, I think from cloud perspective, it's pretty mature in terms of people are well aware of the potentials what cloud can do. Big data is also the same. People learned a lot of lessons over the last few years. What works, what doesn't. But AI, I think, is coming up with the momentum. the blockchain probably is very much experimental right now, right? So that's how you read this curve, and maybe in 3 to 6 months down the road, then there will be the different things falling on this, this chart, right? I'll just say I just want to point to one thing over here. You see, this is also from Gartner, but democratized AI is the first bucket of what's happening in the AI or this big chart. Why is that? Because when there's new technology coming into the market, many players are trying to see where the opportunities are. The big players like Microsoft, Google, IBM, Amazon is trying to do this. It's trying to do this to make machine learning or AI easy for even regular people. Right? Probably maybe let me take a small poll over here. How many people here are like call yourself maybe no data science or data scientist? 3 or 4 people. Okay. How many people feel you more like a developer? Developer. Okay. Developer. Okay. And I know there's also people like as a business analyst, right? And if you go for like a big data shop, they're doing this, training tracks. Usually that has a data scientist track and a data engineering track, right? But I think it's now being a little bit converged. Like now you have seen like a full stack developers or full stack data scientists, right? So these roles actually changing over time, and they fill into this map in a different way. And I'll also share with you in further down. But really, what is AI, right? AI starting from 1950s. It's really about how that machine or computer mimic human being. It had this element how to sense or read from outside, right? That's called AI. But machine learning is start from 80s. It's more about like using statistic model, reading data, and that machine to learn from there. That's called machine learning. Deep learning is a subset of machine learning. Machine learning is a subset of AI. And this deep learning, people seeing this is like a driving breakthrough is because we have 3 things now, right? One is we have a lot of availability of the computing power, right? Both from cloud perspective, from GPU perspective, right? And then we have a lot of data now, right? Data are easily available, accessible, thanks to mobile or social media and such, right? And then the third one is also important. There's lots of research and development, both from academia or like research labs, develop more advanced algorithms and frameworks to help us, right? So I think that is contributed a significant part of why deep learning had the opportunity to take off for the last few years. Yeah.
You just mentioned about, sorry, my voice.
Sure.
So what are the areas being included in full stack data science? Because I just came across this word here itself.
Okay. I guess if you survey 100, 200 data scientists and ask them what they do, then you'll find their day-by-day job differing significantly. If you're working with a very large company, and say in Wall Street even, sometimes you're just working in a research department. Your job is only, develop models and their PhDs and quants, and so they don't really need to be doing something like you're working in a startup, which you need to like wear many hats and do many things. In a very much sense, if you're working in a startup, very likely you have to develop applications.
So something like the person should be knowledgeable of the ETL, the data manipulation platform, the data science.
Yeah, I think which usually means that your knowledge will be crossed a little bit broader from the roles what I mentioned, like a data engineer, developer, data science, right? You need to know a little bit every area, right? Um, but these people usually have, yeah, these people usually I see nowadays being on demand in that the like first tier internet companies, because they they can assign these people to anything, right?
Yeah, we can, take example of as a regular doctor who's just an MD, not specialized in one thing, doing like everything on the regular medical checkup. One who specializes. That's the
Right,
way we
right.
can think.
You can be really good, be a specialist too, right? I mean, if you really focus on that, then you can be, yeah, you can focus on one thing. But there's also some other doctors doing general everything. Right, right. This chart actually, I saw this when I was attending Spark conference. They talk about why AI is hard or challenging. Because if you look at the black box in the middle, it's kind of like a machine learning code. How do you code and train the model? And that probably is somewhat a small part of the whole solution in from engineering perspective or from system perspective, right? So if you look at it, is you need to get data, you need to collect data, right? You need to verify and clean data. You need to extract the features. Uh, you have to have tools. You have to manage resources. You have to provide infrastructure. So that is pretty common if you're working in enterprise. You know that, right? But machine learning is a driving force to lift all the other components with potentials. That's why they're here. Right? That's why they're important. They're important, but they're not only component to lift the whole system, right? In order for a system to work end to end, you need to mobilize other component or department or people to help you to finish this end-to-end pipeline. Yeah.
So you work with your clients, these are enterprise, right?
Yeah.
Big companies. And I work for a big company. And what I'm seeing is, for one scenario, you could service some companies, few organizations, they need this infrastructure to hold you with. It's been, and again, I'm not gonna, it's been traditionally being, roles into the IT, right?
Right.
But this IT, their traditional database or DNS,
Right.
they had that extensive background. And then now they're being, you know, um, tackling this new structure. And my feeling is that, not many of them understand the whole process or the end goal, and so it's being treated like a transaction data or storage. It's you get the data there, and then you're structured. There's the structure, so you're just dumping it. You're not designing properly the data. So the data design piece could leverage tools. And the other thing is they would integrate some, I don't know, but that's my frustration.
Okay, thank you for the comments. I kind of know what you're trying to say. What I read over here is on the there's two sides of this coin, right? On one side, people seeing opportunities, and on the other side, there are a lot of challenges, right? But overall, things are moving on the positive direction. It's just like that curve. You don't know how quickly we overcome that.
I'll say it this way. If I told you for 40 years that that wall is purple, you're going to tell me that wall is purple. 40 years I told you that wall is purple. So you have silos.
Right.
You have business logic is in the wrong place.
Right.
You have business units with their own P&L statements.
Security.
All that went into the box, and systemically, they have taken a micro focus on each application. That architecture, this thinking is science fiction, and most of them are trying, because what they're doing is they're trying to take that little black box in the middle and magically pretend all the other things are just going to resolve themselves to make that work. And there's an educational curve here that is massive.
No. Some, they don't even see the small box.
Yeah, just do something.
Yeah,
That's the problem. Why
but
are you building this? Don't you know the end goal is?
I do agree. There are a lot of organizations not really, even really get to the 101 what machine learning is, and you may have a few people in the organization know exactly how it works, but to get a team, a department, few hundred people to be aligned on the same page, we're not there.
Good luck with that.
Also, I know a product manager working in a very famous firm for data science and machine learning. And he had this chart, and it's really, I try to, the story I'm trying to tell here is, on one side, there's a great opportunity. We see a lot of innovation. But on the other side, there's a lot of dynamics. It's so busy and fast changing, right? And this is just compare what happened from 2017 to 2018. It's pretty current. That's, again, it can be biased view of what's happening, right? You can see when I started time with IBM 2 years ago, we're looking for Spark, right? We think of everything we're going to rewritten in Spark, handling the big data, and we'll build a Spark ML on top of it and do all the machine learning, right? Then deep learning come out. Then where you fit this deep learning into Spark, framework. So that's Spark, right? And then there's TensorFlow, right? TensorFlow was shooting up very quickly. I have another slide. I want to have some discussion with you guys and see why, right? Then Cafe also coming pretty strong, and probably this is going up further now, right? The Flink, some people still think that's there, and some people think they're not. H2O is also Java-based framework, and also they provide a lot of. I go to the conferences and I see they actually all over the place, presenting or trying to enter the market. So as people like us, right? What do we do with this, right? Are you learning this? Just try to catch up everything, or you focus on one, right?
Well, that's the problem, right? This goes back to the 40 years of what people will do. You learn something by rushing to learn one of those things, and the problem is that's not the problem.
Yeah. But sometimes it beats something right. Then you consider they're lucky, right? But some people bet them wrong. Then you consider that's a waste, right? But overall, I think it's a good thing, It gave an opportunity for innovation and a lot of new things coming up. So that's the positive side of the story. On the other side is, all these things eventually will settle down. You just don't know when. It's 2019 or 2022, right? You don't know. But some people choose approach. You do whatever you can, and you learn as much as you can. That's fine too, right? Depends on your resources or commitment.
We can talk about these challenges. If you go back to there's a group of challenges. Why those are challenges? There is a place for the Microsoft Excel. Okay, SQL. I've been working with that. I know what is it. But why there are challenges? I'm a bit confused there.
I think this is also in line of how Gartner has this magic quantum chart, right? So visionary means on this side is you are innovators. You are trying to do something new and
Yes. The challengers is, are they going to be replaced?
challengers. I guess challengers. But yeah, they're on the top, right? On the top means they hold a large market share. They still hold a large market. What's on the challenger leader? They hold the largest market share. What's coming out is the niche players. The best is the leaders. Visionary, they're innovators, but they haven't taken over the market. This visionary may take the market from that challengers.
It means the future of challengers is looking a little bit, like.
I wouldn't want to be in that challenge process.
You wouldn't.
Okay, got
You
it.
wouldn't be. Oh, Microsoft.
This is in no way try to say which one is good or which one is bad. We just try to understand some of these, buckets where they fit over time, right? Where they move. I mean, SQL will be there forever, right? don't be freaking out because some of these are not on this top left, top right, right?
So we look at this chart saying, I'm running a business to try to get something done. Where do I want my staff skill sets to be? That's how we use that.
Okay, so this one is more as my company or IBM's view why enterprise is struggling, right? And I can take the different buckets and talk about a little bit further. From data perspective, I go back to this gentleman's point. The number one problem is data silo, and remove these data barriers and towers and getting data accessible to at a company level is hard. It's going to be hard for a long time. It's not technology problem. It's
Because I'd actually break that into three. The first is data resides in silos.
Mhm.
The second one is business logic is everywhere. So if you have
That is
business
suppose
logic-
blockchain can help to solve, maybe.
Business logic sitting in store procedures, then you got a real problem, right? How are they gonna get that?
Yeah. I guess the challenge right now is why small startups don't have that legacy problem, right? Because they don't need to worry about that silo or barrier and the investment already. They can start from scratch and fresh and new. But enterprise investors into something, they already have a copy, a code, a data there. You are double investing. Where is your ROI, right? So that is their dilemma, and they have to retrain people also, right? What do you do with those SaaS programmers, right? If they are there, you're not going to fire them. You have to retrain them, right? So data is a problem.
So we can look into the things, the data things in other way around as the data is already there. Yeah, being stored in the silo, but there is no one has come up with an innovative idea, innovative business case. How we are going to bring the value out of that?
Actually, that is where this data scientist or data analyst was the value add, right? Because data scientists supposed to be able to uncover insights or values from this data the traditional, technology wouldn't be able to find.
I think that's what the AI is, that predicting the good value.
I mean, we usually just run some of the simple, aggregation or reporting, BI, or even somewhat basic machine learning, but now you have more methods to do this, and you can find something in terms of outcome you've never seen before, or outcome much better than before, right?
So your challenge, the reality of the current state today. Again, I love the example, my example, that was perfect. And I built 40 years around everybody thinking that was perfect. So your first problem is you have no business incentive, which you mentioned before, or there's no perceived business incentive. The next problem is something as simplistic as contractual issues around that. And what can you and can you not do contractually with that? So to take that and really create a data governance role, and be able to say, and I hate the term, but to create that data lake and be able to then send those pieces out in a meaningful way is a humongous undertaking. That we haven't had, the industry has not yet had the problem. There's companies that are working around the industry trying to solve this. I know a couple, but we haven't had that aha moment that says, we're going to bring this down and allow you to manage it so that all those rules and regulations you work against are adhered to. That's a huge problem.
Yeah, I agree. Yeah. So what's also new for enterprise is they are just getting the starting point on the journey to deal with unstructured data. And that also introduced a new, SSQ, that's framework, right? So that many of these frameworks are trying to solve some of the unstructured data problems, which the older tool sets doesn't offer the robustness for that problem, right? The governance, yeah, governance is in terms of security, in terms of getting the data lineage, having the single version of system of truth. The skill sets, this one I think is in some sense we're saying there's a shortage of data scientists, but on the other sense you heard like so many people learning data science and so many people claim they can solve data science problem, but I think there's a gap. On one side, the company needed that skill set, but people having that skill set doesn't have the other skill sets to fit for that job. So we say data science needs three things, right? One is computer programming skills, statistics, math, right? Then domain knowledge, right? The challenge is how do you find someone from another company or another department and come to my group and take on my job immediately, solve the problem, right? So the learning curve is interdisciplinary. It's not just one thing. But I think over time, this barrier will be lower. And that's my topic today, right? To make it easy, hopefully.
I think everybody is learning data science, but they don't have deep understanding what's really going on, and they don't have knowledge of other.
I think it's two sides. One is learning, but also need practice, right? And then the other side is even you learn, you do. Did you produce that outcome at the scale? At the scale, right? It's not just an outcome, but a big outcome, right? Tools and infrastructure. I guess these are definitely going up and moving fast. Then I'll just take a Watson Studio as a general AI workflow, and this is actually not just for IBM Watson. I think this probably apply most of the AI platform and tools. So number one is provide the capability to connect data, and connect data both from structured data or unstructured data perspective, and dealing with real-time batch format, internal, external, right? Go back to that that slide, data access, data silo problem. The second one is about data governance and data catalog or knowledge lineage. How do you index data? How do you manually and automatically receiving that data and make that index and make it searchable and provide an interface for your team to manually further clean up that data and make that ready, right? Prepare data for analytics. That's probably more traditional ETL and type of work, right? That's somehow related with the previous one, but more in terms of getting data visualized and ready to be processed, and maybe do some heavy process before you send to machine learning model where they can be consumed, right? Because if you don't have that proper feature deeply understood or knowledge in that particular data set, you're just shooting in the dark, right? So I think that people won't just go there just do deep learning or machine learning. They actually should ask a lot of questions. Do I have that insight in the data in the first place before they start coding or learning, right? And these tools are supposed to be low cost and a little bit agile than the next one. Because the next one probably is more expensive or require more skill sets or take a longer time or even be more expensive.
So I'm a company that I have a bunch of data stored. I don't use AI in any level, but I want to enter this new phase, this new technological phase.
Mm-hmm.
I have a bunch of data in different formats.
Mm-hmm.
I have my maintenance department has one database. My sales team has another database.
Right.
They probably do not talk to each other, and they are simply putting texts there. Let's say they are all in text.
Right.
Be even harder.
Mm-hmm.
So by using these three first components, I would be able to understand what's in each one of those databases and structure each one of those texts.
Mm-hmm.
Is this what we would
right?
do?
You think about just think about you do traditional enterprise data. Say you have if you picture an enterprise company, right? They usually have 500, even 1,000 different systems or databases, right? There's no easily a single global schema for all, but you need it, right? But why we are operating in this way? Because enterprise is operated at a department level. And that is required because that's how your business decision being made. You're not going to take all this decision to the headquarters and then come down, right? Sure. So this has been done for a long time this way. But now we have a need still to centralize this data and understand what's my data asset at a corporate level among 80 countries, 500, 1,000 systems, right? So you can only do that one step at a time. It's not like overnight. But there's certain areas or certain data has more value than others. Mm-hmm. And that's where taking some good learning in terms of practice, such as where you can drive automation, right? Where you can bring in revenue, right? Where you can cut cost, right? Where you can reduce risk, right? These type of things are the first few areas you start looking into before you tackle, say, I want to build a global understanding of all the data assets. You know, so these tools depends on the organization, and we have this curve, maturity curve. Some organizations are pretty advanced in terms of analytics or machine learning. Some organizations are pretty, immature, right? But just for us, we need to understand there are different customers. There are people are very advanced. There are people just in the beginning, right? But we all learn how to take this journey.
Did you ask something?
Okay, if a person starts learning, machine learning and deep learning, they know how to code and stuff. How are they able to choose which industry should they focus? Because you need to know what's really happening in that business and how can. It's not just learning the tool I have in my pocket. Like, let's say for the real estate, somebody needs to have the knowledge of the real estate to use that tool to make that machine learning useful in that real estate or other businesses like that.
Some people choose this, by choice. Some people just being, chosen by other people to do this. Right? I guess, if you medical school students or something, and you interested in technology, then by nature you just enter into that domain, right? I'll say, there's certain industries are harder than other ones in terms of opportunity. I know that high tech, telecom, or even financial maybe had more opportunities than others. Say healthcare is big, but healthcare in terms of the data, they have a lot of challenges in terms of compliance. Also the technology, the current landscape in the technology in hospitals, things like that. But healthcare, say, if you in insurance, right, they're definitely more advanced.
So, where into the pieces, I understand the question, but I answer it differently. So let's say that you're in R&D.
You could have 30 minutes. Right?
At the end of the day, you can be in healthcare and your knowledge. At the end of the day, you can be an engineer for a you could take that same skill set and then to photography and look at that. At the end of the day, you're still processing power. So at the end of the day, it's a special.
I should stand here so people can see this. I can see. Okay. This chart is just a little bit of just from the technology stack perspective. How do you build an AI platform? So the previous chart, let me go back. Yeah, sorry. So then the next three bucket is building machine learning models, and both programmatically and also visually. But the important thing is they all use open source. The underneath is more open source, no proprietary. Looking back 20, 30 years, there's not very many successful analytics tools built on proprietary. Over time, you see open source taking over. Then you have GPU and capabilities we built in. Deploy model is probably, if you haven't done that, then this is something, I want you to have a takeaway today. It's just when you train a model, you have to deploy it, make it to be used by a program. And that is what I said is building an AI application.
Can you say something about transfer learning? So on the fourth
Transfer learning?
you have pre-trained models.
Right.
And you're just ready to
Right.
deploy the data.
Right.
Are you running some validation? Is
Right.
going on behind it before
Yeah.
training,
Yeah. I mean, you have a program, you read the data, right? You train a model, and then that training process is an iteration, right? You can
right.
you get new data, more data, you train again, right?
Research parameters.
Right. So transfer learning, or later on what I will show you, this custom model is built based on one particular set of base model. And then you can customize that model based on the new data or new algorithm you developed.
Or you do identify like what your
Right.
what you want.
Right. So it's just for the tool set perspective, right? Jupyter notebooks, RStudio are pretty common and popular. About 2 years ago, there's a debate, notebook, I was using Zeppelin and other tool sets. But basically the same, you're writing Python programs or Scala or in IDE like that. But more importantly is you develop also using the program, you develop a set of API where you can interface down and out, left and right? So API is important to develop an open system. I won't talk too much. I think that's interesting of time. I'll talk a little bit on this deep learning and in terms of where the Watson Studio, this tool set can help, right? Training deep learning is still not trivial. Right? If you invest so much time, so much resource, you definitely want to get a good outcome. And these type of tool sets take some experience, right? Take some experience. So who here have used TensorFlow? Okay. Keras. Okay, that's fine.
Keras and TensorFlow.
Okay, good. I'm not an expert. so everybody give me one reason why TensorFlow is good.
Why documentation?
Documentation is good. Okay. Huh? Google build it. Okay.
I see it's faster than the deep learning R counterpart.
Fast. What do you mean fast?
Like it can even run the modeler and the concurrent threads compared to neural network. Neural network as R counterpart. But deep learning.
Okay.
Which has more multi-threaded and also like
okay, multi-threaded.
Faster, easier, a huge community that you can ask questions.
Yeah, open. More people use it, right? So I think that's a pretty good indicator, right? It's popular for a reason, right? But underneath, I'm trying to read this in a way is, you can deploy this into multiple type of hardware devices or frameworks, right? You can natively, naturally deploy into GPU, Android, iOS, and not all the framework can do that, right? That's one thing. Distributed. I mean, you have a framework. If you want to get them distributed into multiple cluster or machines, you have to rewrite all this code. And TensorFlow offer that natively, right? Front-end interface, because I know that which one? MXNet? Yeah, offers R, right? Not all the people offer R. There's all Python stuff, but now they offer. I think they offer Java, C++. It's important, right? Then more people can use it. If they're not ready, I like it. I still have to learn something else. Keras, right? Keras, Keras website is also pretty good. Yeah. So I think there's many reasons for that. But generally speaking, they're flexible and robust. And then you have a larger community, then it's grow faster, right? But until one day, maybe not, right? Because I was thinking like Spark is perfect. Now you have a iTouch or something.
They're building the learning to Spark now.
Yeah, big DL, right? Yeah. But it's not from the very first day. They actually source from the other product.
Yeah. They're hard to integrate muscles.
Yeah. So how many people played a little bit with the CNN convolution neural net? Yeah. Yeah. So is it? So tell me, what are the challenges to learn this? Or is this? Can you teach people in how long take someone to learn this?
Depends on how deep you want to go. Like, it depends if you want to learn it from scratch or understand the high level concepts.
Right. So say middle, you can use it to do one first, give you a data set of, you can do this end to end and training and evaluate and understand what you do.
I think one needs to have a little bit of background on
Yeah.
machine learning.
Yeah.
You can't just jump it out.
No. Yeah. There's one time I was listen YouTube or something, and this guy saying, "Okay, I'm going to teach you, CNN, convolution neural net." that moderator said, "Okay, good luck." It depends on the audience, but for some people it's easy, but for other people it's hard. And go back to that gentleman's question, right? You have an organization, you have two people, no deep learning, but everybody thinking they're geeks and they only, run something, very special, and other people don't know I'm part of it, right? So that's no, that's not my point. My point is still a lot of parameters to tune, right? Still a lot of parameters to tune to get a good outcome. So even you understand it and implement it, implementation part is still, effort, which is fine. I'm not saying this is bad. What I'm saying is, you just need to understand the nature of the beast, right? This is a paper, like you take a research to write a paper, and then they design architecture. How do you build a platform? And if you pay attention to the market, there are probably like 200 companies trying to do this nowadays, right? But underneath this, the bottom layer, if you understand that you have a special hardware, any new hardware coming in, then the top layer had to have a way to interface and utilize these capabilities, right? And I don't think the GPU is the end of this, right? Or TPU or others, right? So that means it's complex, right? Effort. Then you have this is called deep learning as a service, platform services. You have to build them as a services. Container registration service. You have to register different type of deep learning service. You have parameter server. You have to have a zookeeper to manage the execution flow, file system, object store, ELK, logging, monitoring. So these type of things need to be implemented as a platform, right? I'm not saying it's not possible, but it takes effort to do it right and do it well. And then the core services is you also have to build a model or services to deploy machine learning model. And these are like all modules or components within the platform, right? Or training service also need to manage the life cycle. You train many times. You have to compare these models, right? Then ultimately on the very top, you need to build these APIs to giving access to other interfaces or other services. So we have this called the neural network modeler, which you can do drag and drop to train neural net. This is not a tool you will learn just in 2 hours or even 2 days. It still takes some knowledge to understand what it does. But I gave your organization, the people who don't know how to write a Python or something, a way or your manager to understand from 1, 2, 3 to 4, 5, 6 pretty quickly, right? I have a small video. I don't know you have an audio here to play.
I think I'll play from your laptop. Yes, bro.
Okay, no, okay, so that's fine.
So this is drag and drop.
Right,
Drag and drop.
right. That's why I mentioned there's a programming way and also visual way, right? And this is nothing new. Just not just IBM doing it. All the players are doing it. All the players doing it. So what I mean is democratizing AI or machine learning means on one track, you're building very deep knowledge to solve problem. On the other track, you get this 1, 2, 3 very easily for people to do, and you can do 7, 8, 9, 10, right? The more people know how to do 1, 2, 3, the more work for people to do 7, 8, 9, 10, right?
So what's the pricing model for your cloud product?
That's the cloud service are in general as a subscription basis, but most small business you can do this like as monthly subscription, and also some of this based on the usage, API transactions, storage, data storage. Like AWS, you put data in, they don't charge you. You take data out, they charge you, right? So there's a new type of pricing schema for cloud service, because you don't know the very first day how many you're going to use. Over time, you're going to use more and more, right? But it's kind of like a rental, right? Rather than own. It used to be, I buy a server and I install all the software in my data center, and I no longer pay charges for the usage. But this is more usage based.
So that would include developing the model and deploying.
That's also that is also depends on, like for IBM, there's a different t-shirt size tiered, right? For the small size, maybe you have a certain number of models you can deploy, and how many training you can do, something like that. But at enterprise, you have a large number, right? Yeah.
My question is regarding, there is a cloud pipeline of AI, and
Yeah.
there is an on-premise pipeline.
Yes.
Which one is going to?
Okay. So his question is the cloud versus on-premise, right? And I know probably where you're coming from. If you work in enterprise, the people talk about cloud, moving to cloud, but also there's a lot of challenges for moving to cloud for compliance or security reasons primarily, right? But also it's going back to that problem, the data silo. The more the data you move out there, you create more data silo immediately, right? But I see the direction is over time, the on-premise is going to adopt the public cloud infrastructure and framework. Because this is modern and new, it's going to be agile and mature, right? You don't reinvent. It's hard to just do something on premise without some big renovation, right, or something new. What's happening on cloud? It gave a reason for them to deploy on premise, use the same framework. So I see right now it's not just a public cloud; it's going to be hybrid cloud. Means that eventually you're going to run the same type of framework, container-based, serverless, machine learning, new workload, new framework, the same as what you do on cloud with on-premise. But it will take some time. Some will come early, some will come new. IBM just released something called ICP, which means whatever I showed you here in Watson Studio is going to be containerized and ready for enterprise. Because the code I already developed, right? I just drop it. And it's going to be secure and easy for enterprise because I manage it, right? Without put this on cloud. But the challenge is you have to train your internal IT staff to manage that private cloud.
The bigger problem is going to be in the cloud is going to be where the innovation is. So as Google's coming out with their TPU processors, that's a speed and a cadence that no enterprise is going to be able to stop in the data center. So depending on, it took land for the depends, right? But who's going to build a new data center starting 2020? Very few people, right? So the question really becomes, yeah, there's going to be workloads that remain on premise simply because they remain on premise. But I think when you watch the speed at which these tools are being updated, number one, the speed and change and innovation of the hardware itself, I don't know if they cannot not go to the cloud. That's not reality. They're going to suck in and give us some features.
Yeah. So I'll cover the last two topics and we'll finish. You train the model, then the model will be used for a variety of use cases, right? You detect cancer, you detect spam, you serving call centers with chatbot, make a recommendation, facial recognition, or unlock your phone, speech recognition, selfless driving cars. So, but this trained result need to be built into something for end users, right? I'll try to give a demo, but since the screen may not show, I have this one. So I have this is how did I do this? How did I do this? I train a custom model to recognize Coke and Pepsi. So I take like 10 pictures for Coke, 10 pictures for Pepsi. I train in Watson Studio. Then I create a model. Then I deploy it. I'm using Watson SDK. And this is my Slack interface. I put a picture there, and this will give me a probability of Coke and probability of Pepsi.
But you did this so with only 10 pictures of it.
Yeah.
It might have been very similar to the training images possible.
They're very. If I create a lot of noise over here, then I need more data. My data are pretty clean and consistent, so it's easy to train. If I have the Coke and Pepsi with lots of background, lots of surrounding things, different shape, different color or lighting, then I need maybe 1,000 pictures, right? But what I'm trying to say is, Watson Studio tool like that, you don't need to write a single line of code. You can train a model. Sure. Some people may ask me, so what Watson is, right? IBM has a Watson, but Watson to start with as a question-answer system, it's like a Jeopardy. You ask a random question, they search like encyclopedia and then give an answer. But first, understand what the question is, then figure out where is the answer from, right? But today's Watson is much bigger and general with many products. A particular one I want to build and I want to try to create is using something called Watson Assistant, which is the engine for communication. So from communication, if you look at it, you have a customer, you have a front-end channels. It can be Twitter, it can be Skype, Facebook, Slack, mobile phone, web app, right? So these are just getting the data in. Then I have a pre-processing. Pre-processing is different type of data, I'm going to have to just remember that Coke and Pepsi, right? The Coke coming or Pepsi coming is a picture. Then I will understand what the picture is. If I leave a voice message, then they will understand what message I'm leaving, or maybe convert that into text. So natural language understanding, home analyzer, so there's probably like a dozen of AI services we build, and you can use these services to understand and pre-process the information coming from the channel. Then we can send this to a service called a discovery service. That is kind of the knowledge of the universe, supposedly. But usually you don't build a universe. Usually you build a domain knowledge, right? Say you have a small call center, just answer a particular set of, say, mortgage questions. So with that data, hopefully you can train a knowledge graph. Then most of these questions can be quickly uncovered and answered. But of course, this is a very small part of front end. If you look at it, it's a very small app. You have to get all this data into the backend services, right? That is the other problem, people need to solve and try to solve. But what I try to do is, I'm trying to build something just from that Coke and Pepsi story. I can build a more interface with more, proper data input. And hopefully I can give a automation, recommendation, detection, and such. Okay, I think that's 6 minutes before 8. Thank you. I can take some questions. I may not be able to show this slide. I have some other slide, but I have some call for actions.
Link to your paper again, this is archive.
Paper. Okay, you want to look at it? Okay.
There it is. You just type it in.
You have two call for actions. You have two call for actions.
Yeah, I am. I'm local. I'm in Bridgewater, and most time I work from home, and sometimes I travel. So I love to meet people, do something together. So if someone want to meet up and talk about some project. Okay.
I'm in Plainfield.
Plainfield. Okay.
Are you Bridgewater?
Bridgewater. Yeah.
Rocky Hill. So.
Rocky Hill. Cool. I'm on the meetups. You can message me, and my name is Andrew Zhang. You can send me email andrew.zhang@ibm.com.
Actually, more formal application or your different things.
Okay. Yeah. I have a farmer background, but I don't consider I'm like more like a drug discovery person or even clinical trial person. I did a lot of commercialization stuff, like sales, marketing. I know the general business process, not too deep. Yeah.
Okay, the second call for action is
the second one, let me see. I forgot.
It is the AI workshop in December.
Yeah. Okay. Yeah. So I aim, if someone interested in doing something together, then, that's something, we can talk. And everybody has different expertise. Like the few people here, like data scientists and know machine learning, deep learning. There's a lot of things I want to do. I see if we have some common interest. You develop something and I can help you something. You can help me something. The outcome we can share, right? We can either run some workshop together or go somewhere. IBM have a conference. I can invite you. We have a Watson Center in New York City. If you have a business, you have interest, you talk to me, I can bring opportunities to take you to the next level, right? So
That'd be awesome.
Yeah. And yeah, and I will try to, this is an ongoing effort. So I'm expecting in December or January, I'll show something a little bit bigger and real.
No. It's, thank you very much.
Yeah, thank you.
Just to finalize, we have, so this meetup, our meetup at Princeton, we have 3 groups. The first one is doing programming, introduction to programming with Python. We are going to have a new second meetup on the 18th for that. This was our first meetup for the business and AI group. We are going to have the second meetup. I'm going to post that on the week of the 22nd. And we have a third group for the math of AI that we still have to make our first meetup. And probably it's going to be at the same week. Well, Andrew, thank you very much once again.
Thank you.
It was a pleasure.
Yeah.
Thank you, everyone. Thank you, guys.
Thank you.
Great.
You guys did a great job for making this live.
Yeah.